In this lecture, we're going to look at redox reactions, which are also a type of chemical reactions. You will learn how to assign oxidation numbers for different elements of a compound. You will learn how to identify if a reaction is a redox reaction or not. And I will also show you how to write half reactions and how to identify oxidizing and reducing agents. So redox reactions are a group of diverse reactions, and these reactions are occurred in a pair, meaning that if oxidation is taking place, there has to be reduction that's taking place too. So in a redox reaction, we should have both for oxidation and reduction both happening at the same time. So these redox reactions and knowing if oxidation or reduction is taking place is not oftentimes easy to tell by just looking at the reaction. In order to know if a reaction is a redox reaction or not, if oxidation or reduction is taking place, we have to assign oxidation numbers first. So let's learn how to assign oxidation numbers first, and once we know how to assign oxidation numbers, I'll show you how you can identify a redox reaction. So in this slide, you see all the rules for assigning oxidation numbers. These rules, you need to memorize them. So first of all, oxidation numbers of any pure element is 0. Pure element meaning all monoatomic elements, also diatomic elements, and also phosphorus and sulfur. Sulfur in elemental form is in the form of S8, and phosphorus is in the form of P4. So the oxidation number of any pure element is 0. Now, oxidation number of monoatomic ions equals to the charge of the ion. And these are basically, you can assign the charge of the monoatomic ions. And once you assign the charge basically equals to the oxidation number. Keep in mind that the oxidation number of fluorine is always -1, and oxygen is always -2, except in elemental form O2, the oxidation number equals to 0, and in peroxides, the oxidation number of oxygen is -1. Other rule is that hydrogen oxidation number is always +1 when it's bonded to nonmetals, and when hydrogen is bonded to metals, the oxidation number of hydrogen is a -1. Keep in mind that the sum of oxidation numbers of all atoms equal to 0 for neutral compounds, and for charged or polyatomic ions, the sum of oxidation numbers of all atoms equals to the charge of that ion. Now, this last one could be like a check mark for you. So when you assign oxidation numbers, keep in mind that the electronegative atoms or elements tend to have negative oxidation numbers, while electropositive elements tend to have positive oxidation numbers. So let me show you a couple of examples here on how you can assign oxidation numbers. So we want to assign oxidation numbers for each one of the elements of these compounds. So first one, H4SiO4 consists of hydrogen, silicon, and oxygen. So the way you want to approach this is that when you're given a compound, you want to look and find the elements where the oxidation number is fixed. So based on the rules, I know that oxidation number for oxygen is a -2, because this is not a peroxide and I don't see O2. So oxidation number of oxygen is always a -2. The other element that I know for sure is hydrogen. Remember that the oxidation number for hydrogen is also always +1. Now, question is on the silicon. So how do I find the oxidation number of silicon? H4SiO4 is a neutral compound. So our rule states that the sum of the oxidation numbers should equal to the charge. So what that means is that the oxidation number of hydrogens, 4 hydrogens, plus 1 silicon, plus 4 oxygens should equal to 0. Now, oxidation number of each hydrogen is positive 1. So we will have a positive 4 from 4 hydrogens plus silicon. Oxidation number of each oxygen is a negative 2. That equals to 0. So from here, I know that the oxidation number of silicon is positive 4. So the oxidation number of each hydrogen is positive 1, oxidation number of each oxygen is negative 2, and oxidation number of silicon is positive 4. Now let's look at I2. So I2 is an element. Iodine is one of the diatomic molecules in an elemental form. It appears as I2, diatomic. And remember our rule, the oxidation number of all elements is 0. Now moving on to Cr2O7 negative 2. Now chromium, we don't have a rule, a specific rule for chromium. However, for oxygen, we know that the oxidation number of oxygen is negative 2. Now how do I find the oxidation number of chromium? So this is a charged species, and the rule is that the sum of the oxidation numbers of each element should equal to the charge of this polyatomic ion. So it means that the oxidation number of 2 chromium plus 7 oxygen should equal to negative 2. Now, the oxidation state of 2 chromium plus 7 oxygen, each oxygen negative 2, should equal to negative 2, which is the charge of this polyatomic ion. So this tells me that the oxidation number of 2 chromium should equal to positive 12. It means that the oxidation number of each chromium is positive 6. You can always double check your work after you're done too. So how would I double check? Now, each chromium positive 6, that gives me plus 12 to check your work. And then you have 7 oxygen, each one negative 2 minus 14, that's a negative 2, and it matches the charge of this polyatomic ion. Now, let's look at the last example here. You want to assign the oxidation number of nitrogen and hydrogen both in ammonium ion. So we know that the oxidation number of hydrogen is always a positive 1. Now, oxidation number of nitrogen plus 4 hydrogen should equal to the charge of ammonium ion, which is a positive 1. So oxidation number of nitrogen plus 4 hydrogen, each one of them positive 1, should equal to plus 1. That means the oxidation number of nitrogen is negative 3. And I can always double check my work. So minus 3 plus 4 times plus 1 equals to plus 1, which is the charge of ammonium ion. Now that we know how to assign oxidation numbers, let's look at chemical equations and see how we can tell if our reaction is a redox reaction or not. So when given a chemical equation, you want to assign the oxidation numbers for every single element of a compound, and then we want to see if going from reactants to products, if there is any change in the oxidation numbers or not. For example, here, let's assign the oxidation numbers first. So we have a combination reaction which sodium oxide is formed, which is an ionic compound. So oxidation number of sodium is 0 because it's an element. Oxidation number of oxygen is also 0 because it's an element. Now moving on to the product, in sodium oxide, oxidation number of oxygen is -2 and oxidation number of sodium is +1. Now let's see what changes do I observe here. Sodium from a 0 is going to +1. So it is changing oxidation number. Oxygen also from a 0 is going to -2. So it is also changing oxidation number. This tells me that this reaction is a redox reaction. Now, in a redox reaction, we gotta assign how the electrons are transferred. So, oxidation is the loss of electrons and reduction is gain of electrons. So now let's look at the change in the oxidation number of sodium and oxygen and see if oxidation is taking place or reduction taking place. So sodium is going from a sodium metal, 0. So sodium from sodium metal is going to sodium ion in the sodium oxide. So from a 0 going to +1, it means that sodium has lost electron. Remember, losing electrons causes the positive charge. So since sodium is losing electron, it's being oxidized. This is called oxidation half reaction. Now, whenever there is oxidation half reaction, there has to be a reduction half reaction too. We're losing an electron. These electrons need to be gained by another element. Now, if you look here, oxygen from a 0 is going to oxygen -2. So going from 0 to 2, it means that oxygen has gained electrons. So gaining electron, this is called reduction half reaction. Now, our oxidation and reduction half reactions need to be balanced too, meaning that the total number of electrons that are transferred has to be the same. So we have 4 sodium here and 4 electrons, and we have 4 electrons here. That gives us 2 O2 -1. Now, if I put these two reactions together, the electrons that are lost by sodium are gained by oxygen, and then the result of this is 4 sodium plus oxygen gas gives us 2 sodium oxide. This is a redox reaction. Now let's look at another example here. This is looking at a covalent compound. So sulfur plus oxygen gives us SO2, which is a covalent compound. So to see, first of all, if it is a redox reaction or not, we have to assign oxidation numbers. So oxidation number of sulfur is 0, oxygen is 0, oxygen is -2 here, and sulfur is +4. So now, by monitoring the oxidation number, sulfur from a 0 is going to +4, so it's changing oxidation number, and oxygen from a 0 is going to -2, so it is changing oxidation number. So this tells me that this is a redox reaction. Now let's look at oxidation and reduction half reactions here. So sulfur from a 0 is going to positive 4, meaning that it has lost 4 electrons. So losing electrons is oxidation. So this is oxidation half reaction. Oxygen, on the other hand, is going from a 0 to negative 2, meaning that oxygen has gained electrons. So this is our reduction half reaction. Now, in order to balance this, we have 2 oxygen here. It means that we have to have 4 electrons. Now, in our redox reaction, we see the oxidation half reaction and reduction half reaction both. The number of electrons that are being transferred are the same on both sides. So these two cancel out. Our net reaction, you have the reaction of sulfur plus oxygen gas. That gives you SO2 gas. Now, there are 2 other terms that we need to know from redox reaction, which are oxidizing agent and reducing agent. So the element that's being oxidized is the reducing agent. The one that's being reduced is an oxidizing agent. So let me show it to you by this reaction. So here the oxidation number of sodium is 0, oxygen is 0, negative 2, positive 1. Here sodium is going from a 0 to positive 1. So sodium is being oxidized, meaning that it's releasing an electron, meaning that sodium is the reducing agent. What does this mean? It means that the electron that is being released by sodium is going to be gained by oxygen and make oxygen to be reduced. So sodium is the reducing agent. On the other hand, oxygen is going from 0 to a negative 2. So oxygen is being reduced. How? By the electron that was released from sodium. Since oxygen is being reduced, it means that oxygen is the oxidizing agent. Now let's look at single displacement reactions. These are usually redox reactions. So in this equation reaction, we want to know first of all if it's a redox reaction or not. We want to know what's being oxidized, what's being reduced, and we want to know what's the oxidizing agent and reducing agent. So let's assign the oxidation numbers first. Oxidation number of magnesium is 0. Chlorine is negative 1, hydrogen plus 1. Chlorine is negative 1, magnesium positive 2, and hydrogen is a 0 here. Now, here the only elements that are changing oxidation numbers are magnesium and hydrogen. So this is a redox reaction because I see the change in oxidation numbers, but the ones that are basically changing oxidation numbers are magnesium and hydrogen. So what I can do, I can actually write the net ionic equation and just focus on the net ionic equation. So net ionic equation are going to be just the elements that change oxidation numbers. You could still include chloride in here too, but just focusing on the ones that are changing oxidation numbers makes it a little easier to see. Now, magnesium, so let's write the oxidation numbers one more time. So this is 0, hydrogen is positive 1, this magnesium is positive 2, and this is a 0. Now magnesium is going from a 0 to positive 2. So from going from a 0 to positive 2, it means that magnesium lost 2 electrons. So this is the oxidation half reaction. So oxidation half reaction. And then hydrogen, from a hydrogen plus 1, it's going to gain electron and it becomes H2. So gaining electron, this is our reduction half reaction. Now, if we add this all up together, electron and electron cancel out, we end up with a net ionic, which is magnesium 2 hydrogen plus 1 gives us magnesium positive 2 plus H2. Now in here, magnesium is going from a 0 to positive 2, so magnesium is being oxidized. And since magnesium is being oxidized, magnesium is the reducing agent. And then hydrogen ion is going from a positive 1 to 0, so hydrogen is being reduced. So hydrogen is the oxidizing agent. So let's look at another redox reaction. This is a single replacement reaction. Here you have the reaction of copper 2 chloride and zinc that gives you copper metal and zinc chloride. So first of all, let's assign the oxidation numbers here. So chlorine is -1, copper is +2, zinc 0, this copper is 0, -1, and +2. So I see changes in the oxidation number for copper and zinc. So I'm gonna write the net ionic equation so we can just focus on those that are changing oxidation number. So copper 2 plus zinc gives copper plus zinc 2. Now here, copper is going from a +2 to 0, meaning that it's gaining electrons. So this is our reduction half reaction. And zinc is going from a 0 to +2, meaning that zinc is losing electron. So this is oxidation half reactions. Now if we put this together, add them up together, we have copper 2 plus zinc, that gives us copper metal and zinc ion. Now copper is being reduced So copper is our oxidizing agent. Zinc is being oxidized. So zinc is our reducing agent. So for each chemical equation, you want to be able to assign the oxidation numbers and tell if the reaction is oxidation reduction or not. And you want to be able to assign which element is being oxidized, which is being reduced, and you want to tell what atom is basically oxidizing agent or our reducing agent. Now for single displacement reactions, we got to look at the activity series to see if our single displacement reaction take place or not. So the activity series will be provided to you, but you want to look at the activity series for ion and neutral metals, and based on the activity series you tell if a single displacement reaction is going to occur or not. For example, in the reaction of copper and zinc chloride, first thing you want to do, you want to assign the oxidation numbers here. So before we complete this reaction, since this is a single displacement, we want to check the activity series to see first of all if copper can replace zinc or not. So oxidation number of copper is 0, -1, +2. So in the activity series, we want to check copper and zinc 2. And look here, so copper and zinc 2. As you see, copper is less active than zinc metal. So copper does not have the ability to replace zinc. So when you go back here, the answer to this is no reaction, because copper does not have the ability to replace zinc.